Hello my dear students and welcome to this lecture series by AKtU. I am Dr. Supriya Pralatpam, Assistant Professor in Vav Banarsi Das Institute of Technology and Management, Lucknow. I will be taking environmental engineering with code KCE 603 for you. Today we will be discussing unit 5. This is my third lecture and today we will be talking about aerobic suspended cultures. As already discussed in lecture 1 and 2 of unit 5, we have already talked about a wastewater treatment system, unit operations, processes and flow sheets. At the same time, we have talked about primary and tertiary primary and secondary sedimentation tank, and today we are coming to secondary treatment. We are coming to secondary treatment. And secondary treatment, we have already done secondary sedimentation tank. Today we will be talking about trickling filters specially. Okay. Now let us come to the next slide. So this slide I have also shown you in lecture 2. The purpose of showing you in lecture 3 is also because I wanted to tell you a little more about this slide. Okay. So what I told you in the last lecture 2 was that what I told you in the second lecture was that we have secondary treatment. So after primary treatment we have secondary treatment, right. So primary treatment was majorly as primary sedimentation tank and then preliminary like grid chambers, screenings. Okay. Then when you come to secondary treatment, either we can go through physico-chemical treatment, means in that case we will be using either physical and chemical systems, physical and chemical reactions, or either we may go for biological. When we talked about biological, we are going to use most of the time we are going to use microorganisms, right. So these microorganisms are going to be especially bacteria, right. So when we use this biological secondary treatment, it may either be aerobic or it may be anaerobic. So in aerobic, what will happen? Aerobic will be in the presence of oxygen. So those are done by aerobic bacteria or facultative bacteria working aerobically, and in anaerobic here we have no oxygen, in the absence of oxygen, and it is done in the presence of anaerobic bacteria, right. Now coming on to aerobic bacteria can be of aerobic treatment. We can have either aerobic attached culture or aerobic suspended culture. So what is the difference between aerobic attached and aerobic suspended is that in aerobic attached, the bacteria, the microorganisms they are going to be sticking on the filter media. The filter media may either be a sand particle or a rock particle or maybe some other medias like plastics, right, or it may be sheets. Okay, we may also have sheets. So depending on that bacteria, depending on that system, we will have different types of filtering medias, different types of attached something sheets or something like that, which will be attached, which this bacteria will get attached to. So in aerobic attached culture, what we will have, either we will have filtering media. Okay, this is a filter media, let us say. In this case, let me say it is a sand particle. Okay. So in this attached aerobic attached, this bacteria will be sticking on the surface of the filtering media, right, or if it is a sheet, those bacteria will be sticking on the surface of the sheets. So the word we have to remember is attach, it is attached to something, right. So as you can see, we have trickling filters. In trickling filters we will have this filtering media which will be here, and those bacteria will be sticking to this media. Then we will have contact beds, right. Here similarly contact beds are also filtering media, they also have filtering medias, right. And then we will have rotating biological contactors. Here we will have sheets, and those sheets will be, those bacteria will be attached to this. When we talked about aerobic suspended culture, we will have those bacteria will be in solution, will be in suspended in the solution, right. So, generally when we talked about this, what we will have, in this case we will have a reactor, okay, any size or shape whatever you want, and those bacteria and the sewage or the wastewater sample will be mixed together, right. So, you do not have any type of surface here where those bacteria will stick together, they will be flowing, they are free flowing. So, here not free flowing, sorry, here not, sorry. So, here in attached not free flowing, and in suspended you will have free flowing. So, the bacteria will be able to move, here there is no movement as such. So, in aerobic suspended we will have activated sludge, oxidation ponds and aerated lagoons, whereas in anaerobic we will discuss it afterwards, we will have anaerobic and facultative stabilization ponds, septic tank, imhope tanks and high-rate anaerobic systems. So, we will be discussing each and every system in one lectures. Today I will be talking about trickling filter, and in my next lecture I will be talking about contact beds and rotating biological contactors. After that we will be coming on aerobic suspended, and afterwards we will talk about anaerobic system, right. So, here is this is a trickling filter, this is diagram shows a trickling filter, and as I already discussed before, trickling filter is a aerobic attached culture system, right. The cultures are attached to this the filtering media. So, as you can see here, this is the trickling filter. So, what you see here is that this black things are the filter media, right. So, what will happen is that the effluent from the primary sedimentation tank, or so they will be, you will take this up through this pipe, and through this channel of pipes what will happen, they will be sprinkled through this sprinklers, okay. So, what will happen, and you have the filtering media here, the black ones, right, and they will be sprinkled. When you sprinkle, what will happen, they the filtering the sewage or the wastewater will catch some amount of oxygen from the atmosphere, right, and since it is not covered, obviously small amounts of oxygen will flow through it. So, what will happen is they will trickle down this filtering media. In the process, those bacteria will get stuck on the filtering media, and a sort of oxidation will take place, right. So, this oxidation of the wastewater through the filtering media is going to give you a very good effluent, right. So, here we have the sprinkler, the filter, this is the feed pipe, right, the feed pipe, and then it goes, and then there is a, so after the water flows down, water will come out of this, you have the collection system, the effluent, right. So, let us talk about filtering media, trickling filter and its mechanism. As I already discussed before, trickling filter is an attached growth biological treatment system wherein wastewater is sprinkled uniformly over a bed of packing materials, or as you can say the filter bed. Okay. Trickling filters enable organic material in the wastewater to be absorbed by a population of microorganisms, either aerobic, anaerobic and facultative bacteria, fungi, algae and protozoa attached to the media as a biological film or slime layer. Okay. So, what will happen? You have the filter media here. So, those organic matter will be absorbed on this filter media, Okay. So, this is a particle of sand, as you can say, and this red color is the biological film or the slime layer. So, what will happen? It will get absorbed the bacteria, the water, wastewater, which is actually you can say that those the see if this is the filter media, those bacteria are present here. Wastewater, when it flows, it is their food. So, you are giving them food. So, think in that manner, you are giving them food, they are taking food, that those organic matters are food for them, they will going to eat it up and they are going to grow fat, they are going to grow, reproduce, right. This is exactly what is happening, they are going to reproduce, they are going to increase their population, right. So, what is going to happen? So, in the process when it gets attached, the biological film and the slime layer. So, filtering media generally consists of a bed of rocks, slag or plastic, dependent on you, right, depending on what is there, what. So, depending on where you are having that, you will either choose rocks or sand, depending on the raw material you have, right. The filter media is typically chosen to provide a very high surface area to volume, because you have more surface area, you have more space for the air to flow, right. Aerobic conditions are maintained by splashing, diffusion and either by forced air flowing through the bed or natural convection of air if the filter media is porous. The settled sewage flows into a dosing device and are discharged through a series of holes pointing downwards, which propels the arms around, distributing the liquid evenly over the surface of the filter media, right. So, they are the settled sewage, they taken out. Now, let us come to the real mechanism of exactly how we trickling filter cleans the effluent. Okay. So, the working mechanism, what exactly is the working mechanism? The working mechanism is that during the course of the operation, the organic material present in the wastewater is metabolized by microorganisms attached to the surface of the media. The biological slime grows in thickness as the organic material abstracted from the flowing wastewater is synthesized into new cellular material. So, what is happening is you have the filter media, you have this bacteria around it, right, and you are giving wastewater. Okay. Those wastewater are going to have organic material. So, it is the food for them, okay. So, they are going to take food from this. So, they are going to eat the food. What will, when you eat food, what you do? You go fat, you grow, you reproduce, you form new cells, exactly, right. So, what is going to happen? They are going to increase their thickness, okay. New cells are formed. So, they are going to increase their thickness. Now, what will happen? So, this is the biological slime, this is the biological, you can say slime, you can say film, whatever you want, right, slime. The biofilm that develops in a trickling filter may become several millimeters thick and is typically a gelatinous matrix that contains many species of bacteria, ciliates and aerobic protozoa and many other microfauna, right. So, obviously, it is going to have lots of microorganisms and it is going to grow. So, and once it grows, what is going to happen? It keeps on growing, it keeps on growing. Afterwards, it becomes too big for the media to hold. So, it is going to fall off. Okay. So, now the process. As the microbial thickness becomes thick, the microorganisms near the surface of the media do not get substrate and oxygen and go under endogenous phase. So, what will happen? It grows thick. So, the wastewater is going to flow like this. So, you are getting this, the uppermost part or the topmost part of the bacteria are going to get all the food. Then what will happen? Those here in next to the filtering media or which is attached, which is the thing which is attaching to the filtering media, they are not going to get food. If you do not get food, what happen? You die, you are not able to work, right. So, that is what is happening. So, they start up dying off and they go to an androgynous phase, or they go start dying off. Okay. As a result, they become inactive and loosen adherence to the media surface. So, they are not able to stick, they are not able to do their work, and then what will happen? They will not be able to hold it, and these things will break off, they will fall off. Okay. This coupled with increase in speed, increase in velocity due to narrowing of pore space between the two adjacent media surface result in slogging of microbial film into the liquid flow, which is collected by an under drainage system. This process is known as slogging, right. So, the process where this microbial thing is sticking and growing and then finally flowing, finally it is going to fall off from the filtering media. This process is called slogging, right. It is a very important thing and you should know. Slogging is in trickling filters. A new film develops and the process continues. Trickling filters is generally followed by a clarifier for separation and removal of the slog film. So, this slogging, the whatever slog film, right, this is going to be the sludge, right, the sludge which you are going to treat in the anaerobic system, right. So, what is the process? The process is extremely easy, nothing. First we have a filtering media, right, before it was nothing. Then since the wastewater is coming, most of the wastewater will have lots and lots of bacteria, right. They will start building up, and then wastewater keeps on falling, they are getting food, then they are finally going to grow fat, they are going to reproduce, make new cells. After some time, this is too much to hold. So, these people are getting food, the inside people are not getting, the inside bacteria is not getting food, and the inside bacteria will start dying off. So, finally, what will happen? This will fall down. Then after some time, the filtering media will be like this again. Then what will happen? Then again this process will increase, again this one, then again it will form new cells and then start. This process of falling down of this material is called slogging. Okay. So, now what we have seen here. So, now let us come to this. This coupled with increase in velocity due to narrowing of the pore space between the two adjacent media surface result in slogging of microbial film into the liquid flow, which is collected by an under drainage system. This process is known as slogging, right. So, after slogging, what will happen? A new film develops and the process continues. So, once the slog material falls down, obviously now it starts from 0. So, you are going to start again. So, now what is exactly here? I will just tell you once again. What will happen is that first we have the filter material. In the starting, we have the filter material, the filter media. Once you start wastewater, your wastewater starts flowing, what will happen? Wastewater is going to have lots and lots of microorganisms, lots and lots of bacteria. So, this bacteria will start sticking to the filtering media. Once it sticks, the wastewater keeps on falling, the waste they are going to have lots and lots of organic materials which are going to be food for this bacteria. And so, when you eat food, what will happen? You will grow fat, you will grow, and then you will reproduce and make new cells. So, they grow fat, they reproduce and they make a new cell layer. This process continues, another layer of new cells, right, then another layer of new cells. So, this is going to keep on getting bigger, but the process of getting bigger means that the bacteria sticking at to the filtering media, the inside, they are not going to get any food, no food for them, right. What will happen? If you do not get food, or they and not only that, those bacteria will start dying off, right, and then they will not be able to, thus adherence will be gone. So, they are going to fall off. So, this will fall off and those this is fall off. What will happen? Not only that, you will have the water sprinkling on the filtering media. So, water is falling. So, this is going to fall down. After some time, what will happen? This will fall off and the filtering media will be back to square one. So, vector filtering media will not have this material. They will be having bacteria obviously, and those bacteria will again start making new cells, right, and the process continues. Okay. So, let us read again. This coupled with increase in the velocity due to narrowing of pore space between the two adjacent media surface result in slogging of microbial film into the liquid flow, which is collected by an under drainage system. This process is known as slogging. Slogging is a very important term for trickling filters, right. Then a new film develops and the process continues. Trickling filters, after what will happen? So, first we will have the primary treatment, right. Primary treatment will be the sedimentation tank, the grit chambers, we will have that primary treatment, right, and the skimming tanks, whatever you want, and then we will have trickling filters, right. Trickling filters, right. After trickling filters, what we will have? They will be followed by a secondary clarifier, okay, secondary clarifier or secondary secondary sedimentation tank, right. So, why? Because whatever effluent will have all of this films, this microbial this sludge, okay, this log films, right, they are the sludge. So, in the secondary clarifying system, they will be sedimentated and they will, those what effluent will go off, it will be quite a good quality. Even you can you can either usko you can send it for you can like discharge it in the river, right, or most of the time we do not require any type of tertiary treatment, but the sludge which is going to be sedimentated on the secondary clarifier, they are going to be they need to be digested, okay, and that we will talk about in the next classes. Now let us go a little bit this thing. So, now we have types of trickling filter. Types of trickling filter will have conventional trickling filters or low rate trickling filter. So, they are simple trickling filters, right. A well operated low or standard rate trickling filter may remove about 75 to 90% BOD and produce a highly nitrified effluent, okay, good quality, very good quality effluent suitable for treatment of low to medium strength domestic wastewater. Then we will have high rate trickling filters. So, this is low rate. So, this is going to run at a very slow speed, okay, and this is going to be high rate. This is going to produce lots of effluent. In high rates, what is the difference between high rate conventional and or low rate trickling filters and high rate trickling filter is the term recirculation, okay. So, in higher trickling filter, we will have recirculation. So, recirculation in the sense we are going to send back a part of the treated effluent from the trickling filter back towards to the trickling filter again, okay. So, recirculation is generally practiced in high rate trickling filters and not adopted for lower standard rate trickling filters. So, what will happen? This is a single stage high rate trickling filter. You have the primary sedimentation tank, right, a trickling filter and a secondary sedimentation tank here, right. So, in conventional you will have this line, but when you are talking about a high rate trickling filter, you are going to send a amount of this whatever is coming out of trickling filter effluent, you are going to send back a part of it again to the trickling filter, right. So, this is a high rate trickling filter, right. So, we may have different types of, we may have either single stage, 2 stage or whatever, how many ever trickling filters you want according to whatever is the need. So, you are the engineer, you decide how many trickling filters you want in series, okay. So, we may have either 2 stage trickling filter, here we will have the primary sedimentation tank and the secondary sedimentation tank, between that we have 2 trickling filters. So, we have 2 stage in the sense 2 trickling filter with recirculation, right. So, the high rate trickling filters, single stage or two stage, are recommended for medium to relatively high strength domestic and industrial wastewater. BOD removal efficiency is around 75 to 90, but the effluent is produced is only partially nitrified. Two-stage trickling filter consists of two trickling filters in series with clarifiers. Okay. So, whatever effluent coming out of this is actually very highly nitrified and very good, but in case of high rate trickling filter, the effluent actually the rate. So, you get the effluent very so, what I am trying to say is that in low rate trickling filters, what you have is the effluent will be extremely nitrified, but the amount of effluent you are going to get is going to be very less, right. But in high rate trickling filters, the amount of effluent you get per day is going to be very high, right, but the effluent is not going to be that nitrified, right. So, it may need some sort of treatment afterwards, but the treatment coming out of conventional or low rate trickling filters are extremely good. Okay, thanks a lot for this. Thanks a lot, and in the next class we will be doing a tutorial, a problem on trickling filters, and I will be talking about more. We will talking more about aerobic attached cultures. Okay, thank you.